And now it's time to review Heron's formula. So let's say that we have a triangle and we have different side lengths. We're given all those side lengths, but we are not given the height of the triangle. And we need to find the area. Well, if we're not given the height, then we can't use the formula area equals 1/2 base times height. So instead, we would use Heron's formula, which consists of two things. The first thing that we would do is we would find the semi-perimeter. And the semi-perimeter just means the perimeter divided by 2. Once we find the semi-perimeter, in order to find that area, we would take the square root of the semi-perimeter and we would multiply it by the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. So I'm going to show you how to do that right now. Let's get started. Let's say that I have a triangle with the side lengths of 25, 56, and 39. Step 1 of Heron's formula says to find the semi-perimeter. So I'm going to add 25 plus 56 plus 39 and divide it by 2 in order to find that semi-perimeter. When I add those numbers up, I get 120 over 2. Therefore, S equals 60. And I need to remember this semi-perimeter because I'm going to use this in the next part of Heron's formula. Now, in order to find that area for step 2, I have to take the square root of the following. The semi-perimeter, multiply it by the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. And you could think of those variables as just the side lengths right here for now. So I have the square root of 60 times 60 minus 25 times 60 minus 56 times 60 minus 39. And now I will start that subtraction. 60 minus 25 is 35 times 60 minus 56 is 4 times 60 minus 39, which is 21. Now this is a lot of multiplication to do, even if I did it off to the side. 60 times 35 times 4 times 21. So instead, I could make this a little bit easier by using prime factorization. And in doing this, you're basically reducing the radical so that you don't even have to find the square root using a calculator. So I'm going to think about what the prime factorization of 60 is. Remember, I can start off with any two factors when multiplied together that would give me 60. So I'm going to start off with 30 and 2. 2 is prime, but 30 is not. 30 can break down into 15 and 2. 2 is prime, but 15 is not. 15 can break down into 3 and 5. So my prime factorization for 60 is as follows. I have 2 times 2 times 3 times 5. So this is all for the number 60. And that will be multiplied by the following. Let's look at 35. 35 can break down into 5 and 7. Those are both prime, so I'll circle them, and then I'll go ahead and write them over here. 5 times 7 times 4 can break down into 2 times 2 times 2 times 2. I'm going to change this one to a multiplication sign so that it doesn't get confusing over there. And then my last one is 21. 21 breaks down into 3 and 7, and they are both prime, times 3 times 7. So now just for a second, take a look at your groupings. I've just kind of deconstructed all of these numbers. And now I'm going to start making groups of numbers that are the same. And I'm going to put them in pairs. So I have 2 times 2. I have another 2 times 2. I have a 3 and a 3 over here, times 3 times 3. I have a 5 and a 5, times 5 times 5. And I have a 7 and a 7, times 7 times 7. If you have a pair of numbers, it's only going to count one time. So when I rewrite this, I'm going to count these two twos as once. 2 times 2 times 3 times 5 times 7. So again, if I have a pair of numbers, it's only going to count one time. Now this is a lot easier for me to actually multiply these numbers. 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60, and 60 times 7 is 420. And I do not need to take the square root of that number because I have already deconstructed the radical. So 420 is the area of this triangle, 420 square units, unless, of course, it says inches or feet, etc. And that is Heron's formula. Not too bad, but I hope that this video helped you to understand it just a little bit better, boys and girls.